Okay, here we are at chapter 4, 4.1, inverses. One-to-one function, uh, it's more complicated than this, but the gist of it is you can't have a y that has more than one x, essentially. So a function, again, remember a function is invertible if and only if it's one-to-one. Again, the symbol for one-to-one is 1 dash 1. So a function has an inverse if only if it is one-to-one. Now, it basically means that every x has to have a y, and no x can have more than one y. That's function. And no y can have more than one x. So it's basically a pairing off, essentially what it is. So every x has to have a y, and no x can cheat. For the y, as long as no y cheats, you're good. So because the y is not repeated, it's one-to-one. It's a function because no x repeated, and it's one-to-one because no y is repeated. So everybody's faithful, essentially. So it's invertible. So it has an inverse. The inverse essentially is kind of cool because these guys just kind of flip flop, just kind of flip. Okay, the x values become the y values, and the y values become the x values. So you see this negative 3, 4 becomes 4, negative 3, 2, negative 1, negative 1, 2, negative 5, 6, 6, negative 5. So they just kind of flip flop. That's how you find the inverse. X becomes y, and y becomes x. The symbol for inverse is negative 1 power. So the y function becomes negative 1 power. This is the inverse function of this function. That's all it is. Here, every x has a y, no x repeats, so it's a function. Every y essentially is here is faithful. No single y appears more than one, so it's invertible. The inverse, you can kind of see 5, 1 becomes 1, 5, 4, 2 becomes 2, 4, 3, 3 becomes 3, 4, 3, 3, and 4, 2 becomes 2, 4, and 5, 1 becomes 1. I'm sorry, I'm playing it backwards. 5, 1 becomes 1, 5, 4, 2 becomes 2, 4, 3, 3 becomes 3, 3, 2, 4 becomes 4, 2, and 1, 5 becomes 5, 1. What does it mean not to have an inverse? Well, here every x is faithful. No x has more than one y. But here, this y value has two x's. So 5 has a 4 and a 2 as inputs. So essentially, you can say that 5 is cheating. So it's not one-to-one. And therefore, this thing has no inverse. So it doesn't make sense to actually do the inverse. Diagram, you have points here that go to these points. Arrows that say A goes to 4, B goes to 1, C goes to 3, and D goes to 2. Notice that every letter goes to a singular number, and no number has more than one letter that it comes from. So it's a function and it's one-to-one. Therefore, its inverse, the circles switch places. So the 1, 2, 3, and 4 goes where the ABCD was. ABCD goes where 1, 2, 3, 4 was. And so 1 just goes back to B. 2 goes back to D. 3 goes back to C. And then 4 goes back to A. This one is not invertible because here I have one x that goes to two different y's. The x cheats, so it's not even a function. Now, even though the y's are faithful, it doesn't matter because the x has screwed it up. So because it's not a function, it cannot be one-to-one. So one-to-one has to be a function first. If it's not one-to-one, then it's not invertible. So it has to be both function and one-to-one for it to be an invertible function. And you see that symbol here, f negative 1. That's the inverse. Fairly straightforward. If I can here, I just wanted to add a little bit more to it. To find the inverse, essentially, of excuse me one second. Here, find the inverse of an invertible function off an equation, like it's f of x equals to a function, f of x equals to the equation, f of x in terms of an equation. The function part, you change it to y. Then you flip flop where x and y were. So y becomes x, x becomes y. In other words, you switch the letters. Then you get everything to the left. You get y by itself. So plus 4 divided by 3. So what y equals over here, that's the inverse function of the original problem. So f of x is 3x minus 4. F inverse of x is x plus 4 over 3. That's the opposite. In other words, the opposite of subtracting by 4 is adding 4. The opposite of multiplying by 4 is dividing 4. And that's the inverse. third power, y becomes y instead of the function g of x, then y becomes x, x becomes y. To solve for y, you take the third root of a third power, cube root, that cancels the third power. And so the cube root of x equals to y, so that's your inverse function, cube root of x. Over here, your square root of x function, your square root of 3x minus 4 function, y becomes the function. Now x turns to y turns to x. Get everything to the left, so you have to get rid of the square root button. The square root function. So you raise both sides to 2 power, and it cancels the square root. Then you add 4 to both sides, and you divide both sides by 3. So while this, again, keep in mind, this is a parabola. It turns out that a parabola is not invertible. However, if you put this in the right domain, this has an inverse. So if x is every number that you can plug in here that's greater than or equal to 0, the domain of this becomes the range of this. That sounds fancy and funky. For me, I hope you understand that that's just the inverse. I'm good with that. Okay, so that essentially is how to find the inverse of an equation. Now, to know that a graph is invertible, you do the horizontal line test along with the vertical line test. So these red lines across are actually your horizontal line test. It's a vertical line test. So in this function, notice that we did in chapter 2, the vertical line test, this will be a function. But the horizontal line test fails because you hit it at more than one point. So it's not 1-to-1. So the horizontal line test, if you hit the graph at more than one point, it's not 1-to-1. Here, every horizontal line that runs through this hits it only once. So it's 1-to-1. You can convince yourself that every vertical line hits it only once. So this function is invertible. It is a function, and it is 1-to-1. Therefore, it's invertible. Notice this one. Excuse me. Going across, it satisfies the horizontal line test. But coming vertical, it doesn't satisfy the vertical line test. So this thing's not even a function first. So once it's not even a function, it cannot be the other two things. So it has to be a function first to go to the second step. If it's not a function, the rest of it is null and void as well. So how do you find the inverse from a graph? If this blue graph is my original function, you put a diagonal line, the y equals x line, and you flip it across. This one. See, what happens if some of it's under the dotted line and some of it's over the dotted line? Well, whatever's under the line, flip it over the line. Whatever's over the line, flip it under the line. Like that diagonal line is like a pivot. It's like a mirror. It flips essentially diagonally, however you look at it. So that is the section on inverses. 4.2 talks about two types of graphs. These two graphs are what are called exponential functions. An exponential function is a number, a base raised to a power. A is the exponent, x is the power. Sorry, a is the base, the exponential base, x is the actual exponent itself. Now, there's a couple of restrictions. The base has to be positive for this thing to be graphable. And the base cannot be 1. Because 1 to any power essentially 1 is a constant function. So this graph is increasing, going upward, if the base is bigger than 1. The graph is going downward if it is less than 1. So essentially that's how you look at it. Those are the two graphs that, or the two base graphs, of what's how it determines how this thing kind of comes about. So let me see if I can show you here. And go back here. Y equals 2 to the x. So if the base is bigger than 1, which that is, let me get my window here. Let's say -10. Let's see how that works. That's kind of this picture right there. See? That's the base is bigger than 1. Now, if the base is less than 1, let's say 0.5, notice how it goes downward, it decreases. Hence your second picture. So as long as the base is less than 1, it decreases. Now, if you look essentially here at my table, I guess. Not my table. No, no, not that one. Y equals stat plot. No, where is it? Well, anyway, the point that it's always going to pass through is the point 101, because it turns out. Sorry about that. This is another value here. Now, it turns out that anything to the 0 power is 1. Dumb. It doesn't matter as long as it's not 0 to the 0 power. So you could take what, 2/3 maybe. I'll just do this real quick here. Anything to the 0 power is 1, so that's why they're always going to pass through 0, 1, the base graphs. Just want to point that out. So essentially, if it's less than 1, it goes down. If it's greater than 1, it goes up. So these guys are actually flips along the y-axis of each other. It's actually kind of cool. So again, I just wanted to point that out. Let me go ahead and clear that and get you back to the picture here. Get you back to this. The asymptote. It has an asymptote here at 0 because if you take a small number to a power, you keep raising the power, it gets tiny, like 1/2 to the first, the second to the 1/4, 1/8, 1/6, like 0.5, 0.25, 0.125, 0.0625, 0.03125, 0.0015, and so on. It keeps getting tiny but never touches the x-axis. So these graphs don't touch the x-axis. They are called asymptotes. Now, if you shift them, that's a different story. But for right now, they don't cross the x-axis. Okay, just to give you a couple of examples here, like I did in the previous one here. Just showing you I did 2 to the x and I did 0.5 to the x. But you can kind of see it. One goes up, one goes down. E is a function that I want you to be aware of here. In your calculator, you have a little ln right there. So I'm gonna do second ln. It gives you the E button. Now E is oh jeez, second ln e to the first, which is E. It pretty much gives you 2.718. It's Euler's number. It's a built-in function in your calculator. So notice that. Notice what I wrote there. It's a built-in function in your calculator. So e to the x is an exponential function, and e is the base 2.718, etc., etc. Oh, excuse me. If you want to talk about how the graph looks, second ln, it's going to be the one that's going to go upward because the base greater than 1. So it's going to be like this again. So anytime you see a graph of E, it's going to be increasing essentially, unless there's a shift done to it. Okay. So what I'm going to show you here is the translations essentially. If you put a minus in the exponent, you want to change this again. The 0 essentially becomes a positive because the y value want to remain at 1, so this whole thing has to be 0. So what can I plug in for x to make the 0 the opposite sign? So positive 2. So if it's a minus 2, it's 2 to the right. If it's a plus 2 or a plus 1, it means to the left. So in terms of the powers, whatever's in the exponent, a negative means go to the right, a positive means go to the left. So the 0, 1 that was a critical point before, the x value changes to a positive because you're going 2 to the right. The x value changes 1 to the left, so negative 1. So you just kind of just shift it this way 2 spots. Shift it this way 1 spot. If you put a plus on the outside or a minus on the outside, In this case, outside the exponent, in this case, plus means up. So 0, 1 that it was before goes up one spot to 0, 2. And it's still less than 1, the base, so you're going down. It's still the base less than 1, so you're going down, except now here you went down 4 spots. So 0, 1, which is right here, goes down to 0, negative 3. Now here's the thing. Because there's an asymptote attached to it, if the graph moves down 4, the x-axis moves down 4, or the asymptote moves down 4 with it. So the asymptote moves as the graph moves. So this is also going to be the new equation for my asymptote. So negative 4 for the y is my horizontal asymptote. Here, plus 1, positive 1 is my new asymptote for my y-axis. So right, left, up, and down. And how does it all stem? It stems from the point 0, 1. So 0, 1, if it goes to the right or left, you change the x-coordinate. If it goes up or down, you add 1 to the y-coordinate, and you go from there. Okay. I'm sorry. Whether you go up or down, you add or subtract that number to 1. That tells you the menu point. And so once you know where the point is, the critical point, essentially you can graph all of these things. And if you know how the graph looks, the base graph, then that should be easy for you. Now you stick a negative in front. Because this base is less than 1, normally the graph looks like this. But when you reflect it about the x-axis, because that's a negative, it kind of does this number. It flips downward. So normally it'll be kind of right here. But you flip it downward. And so the point 0, 1, he changes to this number, 0, negative 4. The point, again, this number, whatever it is going to multiply to the 1 here. So 0, 1 goes up to 0, 4. The asymptote stays the same. So if it's positive, it stays upward direction. And this number gets multiplied to the 1. If it's a negative, it flips down, and this number gets multiplied to the 1, give your new coordinates. Now, applications, as it were, there is what's called compound interest. Compound interest has two formulas. The first one, essentially, A equals P times 1 plus R over N to the NT power. That is what's called compounding. N represents how many times per year they're going to charge you interest. So compounding means a time that they're going to charge you interest. In the second one, you have the E function again. That is continuous compounding. Theoretically, that's all the time. You're getting interest every second of every minute of every hour of every day, etc., throughout the year. Your P is your principal, which is how much money you invest, or how much money you borrow, what's also called present value. Your interest rate, R, it's a percentage they're going to charge you of interest. T is how many years you borrow or invest the money. N is how many times a year they're going to compound the money. There are words like monthly, yearly, daily, weekly. So it's how many times a year they're going to charge you. E is Euler's number, 2.718 that I discussed a little while ago. So let's track these. Joe borrows $5,000 compounded monthly at 5% for 10 years. How much money would Joe have to pay back? Well, in this case, the present value is 5,000 because he borrows. Now, monthly here. Monthly tells you essentially how many times a year. Well, there are essentially 12 months in a year. So N is 12. T is 10 years. And your interest rate is 5%. But when you have percentage, you have to move the decimal point 2 places to the left. So you get 0.05 as a decimal. So anytime you have a percent, move the decimal 2 places to the left and get your decimal 0.05. So the formula with the numbers plugged in, P r over n raised to the n times t power. So 5,000 times 1 plus 0.05 divided by 12. Raised to the 12 times 10 power. And the answer is $8,235.05. Just to kind of show you that here. Just the way you kind of see it. 5,000 times parentheses 1 plus 0.05 over 12, close parentheses, raise it to the 12 times 10 power, as this thing says. And that's how much money he's going to have to pay back. And if he borrowed 5,000, he has to pay back 8,000. That's a little over $3,000 of interest. That's kind of a lot. But that's how interest companies work. You know, they want to make profit. So that's essentially number one. Number two, it says Mimi invests 200,000 into an account for 5 years, compounded quarterly at 3.1%. Uh, how much will their investment grow to? The present value is $20,000. That's how much she invested. The number of years is 5. Quarterly, there are 4 quarters in a whole, or 4 quarters in a dollar, essentially. So n is 4. 4 quarters in a year. And then 3.1%, move the decimal 2 places left, 0.031. You put into the formula, and you get 23,329. If you want, let's see. 20,000 times parentheses 1 plus 0.031 divided by 4, close the parentheses, raised to the parentheses 4 times 5 power. $23,339.21. And it gets dollars and cents, so we round to the nearest second decimal. Or two different two decimal places, excuse me. And then Mike lends out $10,000 compounded continuously. Continuously is this formula. The only time it says continuous compounding is the second one. So 10,000 is your present value, 4 years is your t, 6% is your ratio, is your percentage, your interest rate. So 2 decimal place to the left, 0.06. Put it into the formula. 10,000 times second ln, which is your e button, 0.06 times 4, close the parentheses, and it equals about $12,712 and about 49 cents. Okay? And that would be compounded continuously. That's how much you have to pay back. But again, this guy borrowed 10,000 and pays back 12,000. So the interest companies get 2,000, almost $3,000 of interest. Okay. So let me stop here for